Hi, I'm Linda Smith with FaceCake. I'm the CEO and founder of FaceCake, and today I'm going to be talking about visual shopping and leveraging AI for personalized product discovery. So essentially, everybody already knows that search is changing very rapidly, but the way people shop today is changing with that, and the way retail is running is changing even faster. So it's all converging to make for a very interesting environment. We have string searches or word searches are no longer the only option, and in fact, keyboardless searches or searches without typing anything in or any text are becoming the norm. And for shopping, this makes a really big impact on the experience and on the results and on the data that you can gather that makes it even more personalized for the shopper. And advancements in AI are increasing the ability to personalize the search experience. So if you think about images right now, visual content is incredibly important. 80% of what you see, you remember, 20% of what you read, and 10% of what you hear. And with the millennials, about 84% look at user-generated content, or the ability to look at an image, share an image, get the metadata or other data out of the image as something very compelling to them, and that's the way they like to shop with UGC. So we started with string search or word search, and that was a real breakthrough and still continues to this day to be very compelling, but things are changing fast. And that is what we're here to talk about as far as visual shopping. So you have geolocation, you also have natural language, audio, and visual search. And each of these we all use probably every day in some component of that. But as you look at shopping more and more, it's gravitating towards a combination or two or three of these. So with visual search, you have the ability to look at like items. So really, visual search, and probably everyone here knows this, but I've been compelled by my CTO to make sure that I explain it to everyone again. But visual search is the matching, using images or photos as input to then find matching or similar products, and then from that be able to use and identify attributes, either one or more, in that image to make even a better and better search recommendation or result from that search. So here we have the basic search, where simpler, where you're matching a like image for a little puppy, and then you have face recognition, and then you have where you are actually identifying components also in the image. So in the suit, you see that's a tie, that's a shirt, that's a 2 or 3 button jacket, whatever, and that's what you're identifying there. Am I talking too close to this microphone? I feel like it's right here. Okay. Okay, so transforming shopping with AI and machine learning. Really, with AI and machine learning, you're able to enables you to extract and identify components of an image, which is very important in shopping when you're talking about visual search. So here you can identify a person, a product, or even metadata. So what is that? Is that a handbag? What color is the handbag? What are the features of the handbag? Remember the whole drama around whether it's a red or pink dress or a blue or green dress? So for different people, they see different things. So what may be your green is someone else's blue. So with FaceCake, what we do is we enable shopping experiences through personalization of product, interactive with them, combining AI and AR into a simple experience. But to make it more and more personal, more and more relevant, and to increase engagement, you need to know, what do they think of when they have a red lipstick? Is it a blue red? Is it an orange red? What is red to them? So when we're talking about how we work with visual shopping, think of visual shopping as combining the shopping visual search with a purpose, where you're making shopping more personalized. So one of our case studies here, and the one we're going to show today, is Glam Scout. Glam Scout's one of our applications where you can take a picture of anyone that you see. It can be a friend, it can be a celebrity, or anyone. This way, Kristen Bell. You could take a picture. We extract what she's wearing, what shades of eyeshadow, blush, and lipstick, and then the user is able to also try those on. So for Scout, we combine AI and AR. So we're delivering a seamless experience. In this case, they get the look and the look for less as well. So you know then what kind of products that they gear towards. Sometimes people spend more on eyeshadow than they do on blush. So all these data points are going into the user's profile. But we're getting data and extracting data from Kristen Bell's image about the makeup, but also extracting data about the user and the products they prefer. So from looking at the user, we can see her face shape, her eye shape, her skin tone, hair color. So we're using AI on all of the user attributes and Kristen Bell's attributes and the product attributes. She likes this image. Why does she like the image? Does she like Kristen Bell? Does she like the makeup? We assume so because she used it in her application Glam Scout. Or is there something more that we don't know? So we're looking at it and we're looking at everything in that image to personalize it more and more to the user. Now, if you have a visual search that gives you these kind of results, our Scout results, and Scout is the ability to search and try, use visual search, and then go into an augmented reality try-on situation. So here, does she like this because she's able to try it on, and does she search more? Yes. You search more, and the more you search, the more you're engaged, the more you try on. In this case, average of 21 products per session, then the more you convert. Engagement leads to conversion. So we're expert at keeping someone engaged with relevant product promotion in session or out of session with what we know about them, and there's product selections. So here we have Kristen Bell, and we're looking at this, and now she's in one of our other applications that's focused on earrings. So we know, did she like Kristen Bell because of that shot, also because of the earrings? So she's able to come in, and we put those earrings first at the top. Those are bobble ball earrings, very popular. And she liked the multicolored one, so we think, okay. And we lay out her options for interaction, her augmented reality interaction based on the earrings and Bobble Bar. Bobble Bar is an amazing company. Maybe she likes the Bobble Bar earrings. And then we throw in another dangle earring with multiple hinges. That's a bright color. So we have our analysis in there, that our proprietary recommendation system that can help place. But we know that she liked that earring, those earrings, or she liked that shot. Again, it might just be she's a huge fan of Kristen Bell, and that was a great look. But we're able to extrapolate from the image and see that these are the earrings that she prefers. These are let's see if she goes for it again. And as she interacts with the product and says, okay, I like this, then that's a way to bring her to the level of a purchase and convert her with our visual search components. So visual shopping meets entertainment. Where is this going? So you're watching Stranger Things, you really want that retro sweatshirt. You should be able to create your own user-initiated commercial. I want that sweatshirt. It's pretty cool. So from there, you're going to be able to look at that and say, this is what I'd like to buy. You can interrupt the show, or you can say, I need to continue watching, or it can just come in as a user-initiated commercial. We know more and more about this user, and this is what they want to see, and this is the show that they love and why they would like this sweatshirt. With FaceCake Scout, you're also able to try it on and actually immerse yourself into the show if you'd like, and see yourself with that product already applied. So we're able to take you to the point of purchase, or maybe it's just a user experience and an engagement that doesn't lead to a purchase. Maybe that's not the objective initially. But this is where we see visual shopping heading, is that any part of entertainment becomes your personally generated commercial back to you, something that's highly relevant. Can be on your image, on your doggy, on anything that you see your own, on your car, and you'll be able to see that and have something to do with that that's relevant to you in order and to execute on something that changes the way that you think of shopping the way we do now. In summary, visual shopping is just we're just starting. This is all really neat and cool, but we're just starting to learn more and more about it. So product discovery is now available from anywhere. Obviously, the phones are everywhere. This is how people are shopping and how they're watching a lot of their content and how they're watching a lot of everything that they're doing. And so because they can take it with them anywhere, walking by a store, anywhere else, even if they're running around the subway, then you have an opportunity to reach them in a relevant, personalized way. And personalized visual searches, as I was talking about, will integrate into advertising in a more compelling situation than what you have now. So currently, we actually do mirror media ads, we call them, where you're able to immerse yourself in the advertisement. But if it was related to the content of what you were watching and everything else, it becomes even more relevant to you. And the numbers really bear it out when you see someone who interacts with the product, a shopper interacts with the product, and they see, I like this lipstick, I like this color, and by the way, to me, that's a blue dress, and we know that she thinks that because she took a picture of it and she engages with it. So whether she thinks it's blue or we think it's green, for her it's blue, and we're able to market the product back based on her actual preferences, based on the pictures that she takes and the data we're able to extract from that picture. Thank you.
Thank you very much, Linda. We've got Paul Roberts up next from Amazon to talk about his experiences at Netflix.
Boom. Okay, so Craig was a little off. It's not just going to be all about Netflix, but it's going to be about other customers that we support. And so let me just begin. My name is Paul Roberts. I cover strategic accounts for AWS. So today I'm really going to share with you guys a lot of learnings that we've had with working with these various accounts. And hopefully there's something you guys can take away from this. So we've had 2 killer presentations with a lot of information, which my bank account might be hurting after my wife sees that one. But overall, I mean, there's been some great information. And so where are we really today with AI and ML? So just before we dig in, how many of you have an Alexa? Wow, awesome. So just last week, Vizio actually announced integration into their televisions with Alexa. And the purpose of this talk today isn't really all about Alexa, but what's actually happening behind the scenes. So there's 2 key technologies, 2 key components of artificial intelligence that's actually running behind the scenes. Number 1 is automatic speech recognition, or ASR. And number 2 is natural language processing, or NLP. So as an example, if I say, Alexa, watch Netflix, immediately what's going to happen is the device is going to listen to what you just said and actually compute it and translate it into text to begin to focus and follow on your workflow. But additionally, what will happen is, let's say I say, Alexa, watch Netflix now. Or I say, Alexa, please, let's watch some Netflix. Regardless of whatever phrase I'm going to say, it's going to use natural language processing to understand my sentiment and what I really wanted to accomplish and then begin the overall workflow. So Alexa obviously isn't the only technology on the block. I mean, we of course have other competitors, but we're seeing technologies like Alexa overall based on our Q4 retail numbers. We saw an 889% increase. So for us in the media space, technologies like this ultimately will make our customers' lives enriched because of ease of use. So here's a quote, and this actually comes from Jeremy Legg, who is the CTO of Turner. We're going through the largest technology transformation since Ted Turner started the company. And the advancements we're making today are enabling us to reimagine what television can be for our viewers. So what does this really mean? Turner, back in November, announced that they're going to be transitioning about 15 petabytes of digital archive footage over to the cloud. So 15 petabytes of CNN's content now needs to be extracted and enriched, and something has to happen with that data. I'm sure some of my colleagues up here today may be helping them with that. But with that said, what does that actually mean? So we've heard about computer vision, and computer vision is one of the areas where I see a tremendous amount of adoption from my customers. So this visual here will kind of depict on some of the interesting pieces of metadata that you can actually extract from a person's face as one example. So whether they're male or female, whether they have a mustache, whether they have a beard, and then one of the things that I'm most excited about is the overall sentiment that is being expressed. So are they happy? Are they angry? How are they feeling? And then other attributes like image quality. So if I'm going through my image library and I want to, or my video library, I want to make sure that that particular frame meets the quality specifications that I'm looking for in order to continue my workflow. So this is just the beginning of how I can extract some of that interesting data. So customers like C-SPAN are already using this technology today. And they've actually indexed 99,000 people. So these are going to be politicians like perhaps like Paul Ryan or John McCain. And so if someone is going through one of the shots and they're walking by, you can quickly say, oh, hey, that's this politician. And so computer vision is enabling people to do things like this. So here's a quick example of what about being able to do this live from video processing. So what this is actually depicting is matching specific people based on that index that you created. So again, I gave the example of using Paul Ryan or John McCain, but this is matching their face. But what about actually doing scene detection or object detection? So again, in the media context, let's say I'm really interested in providing a richer interface for my advertisers. So let's say I have a Coca-Cola or a Pepsi can that's hidden somewhere in the background. Through object detection, I can say, oh, at this particular timestamp, I see this Coca-Cola And now I can provide that information back to my advertisers and allow them to perhaps throw an advertisement to my end users based on the timestamp, based on their location, and based on the content they're looking at. Okay, so we were just talking about computer vision, and we talked a little bit about ASR and NLP, but another huge area is sentiment analysis. And I've heard this covered a little bit as well. And sentiment analysis is a huge area of investment, and the reason is that companies like Netflix, Disney, and Apple, they're on target to spend over $10 billion this year creating their own original content. So if you're going to be creating $10 billion worth of content, you want to make sure that you're making the right investments, and it's going to be worth your users' time and the studio's time and the actors' time to actually create this. So how can I extract interesting information from my content? So here's an example. Here's a demo that my colleague actually put together. And what this is doing is he's actually playing a video game, and my apologies if it's difficult to see, but he's playing a video game real time in the bottom right there. And as he's playing, you're able to see how he feels. So is he angry? Is he sad? Is he enjoying the game at the moment? Now, why is this important? So I'm sure many of you have actually been in a movie theater, perhaps one of the new Star Wars films, I know personally when Harrison Ford walked back in one of the frames and Han Solo came out and the crowd erupted. Everybody was clapping and really excited, very nostalgic. By capturing sentiment, you could have screeners where you're capturing, hey, do people actually like the content being produced? Are they happy with this particular actor? Are they happy with where the shot is? Was this in Lake Tahoe or was this in Palm Springs somewhere? So by tracking sentiment analysis and comparing the actual timestamp, you can provide a richer feedback loop to the studios, to the actors, and to the script writers. So, okay, so we have sentiment analysis, but what about recommendations? And artificial intelligence-powered recommendations have kind of been around for a long time. I'm sure many of us have used services like Pandora. So just by show of hands, how many people either use Hulu, Netflix, Amazon Prime, or any of these streaming services? Pretty much everybody. Even the guys back there, great. So there's this old adage, don't judge a book by its cover. But there's some data that says something against that. So I'm going to ask a question. Feel free just to shout out some answers. But on average, when you open up one of those interfaces, and we all do it, we're scrolling through, how long do you think it takes for you to decide, how many seconds do you think it takes for you to decide, I want to watch that one? Anybody? Okay. All right, we got a bunch, 30 minutes to 10, 20 seconds. It's 1.8 seconds. So, don't judge a book by its cover. So if I'm spending $10 billion a year on my original content, and I have to have the right piece of content, and I have 1.8 seconds to grab your attention, what do I do? So Netflix has actually solved this problem. And they recently published on their tech blog how they did this. So they have different shows here. So some of them, The Crown, Stranger Things, Dark or Black Mirror, many of which I'm sure a lot of you guys have seen. But for about 1 hour of content, that's about 86,000 frames. And those 86,000 frames or images, they're looking for what's the perfect piece of content that I believe will resonate with my users. And when they do that, they're actually looking at shot composition. Is it following kind of the rule of thirds? You know, is the shot zooming in or zooming out? Who's the actor or actress within that specific frame? How are they feeling? Are they happy? Are they sad? Are they perplexed? And then what's the overall location? So they're factoring in all that data, and that's just for one episode. Let's say they have 10 or 12 episodes. You could quickly have up to 1 million. I just got the time limit. You can have up to 1 million images. So Netflix goes through their entire catalogs and quickly classifies, this is going to be the best image while you're going through in those 1.8 seconds for you to say, I want to watch this piece of content. So it's very interesting, and they're actually doing a lot of this analysis today on AWS. So what does the future hold? So we have other use cases right now where customers are exploring things like automatic subtitling. So when you think about automatic subtitling, There's a whole component of machine translation. So I want to translate from English to French or English to German, and then I want to be able to generate subtitles automatically. And this is something we're seeing a huge investment. Recommendation engine, so making recommendations based on what content you should watch. Number one, saying, hey, I think you're gonna like this action flick or this drama, but then also what we just saw with Netflix, where it's specific, images that we think is gonna resonate with you. So there's a lot going on within this space, whether it's retail or within the M&E, but if you guys have any other questions, feel free to come talk to me afterwards. Thank you very much.
So we're going to have Logan Ketchum next from Veritone.
Hi, everybody. All right, I'm going to go over a couple of slides because what I touch on in Yves' left is kind of apropos to what he was discussing today. But first of all, I'm Logan Ketchum with Veritone. And really what we've created, you could think of it as the first operating system for AI, right? So we have over 170 plus engines, and we define a cognitive engine as machine learning or AI algorithm written by the Amazons, Googles, Microsofts, two guys in a garage. And so we just, depending on what the application is, and we're able to, with our technology, orchestrate these engines, right? These narrow engines, and I'm gonna get into that, to solve more general business use cases across M&E today. So we work with iHeartMedia, I can't say, so NBCU, parts of NBCU, CBS, ABC, et cetera. And I'm gonna dive into some of those use cases, but first I just kind of want to give the high overview. We kind of went through this, so why the OS approach, again, revolves a lot about what Yves said, and that is today we're seeing an explosion in what we'll call narrow intelligence engines, right? So these engines are built by specific engineers in specific parts of the world using specific training data and to solve really specific use cases. And so the challenge is that these cannot be generally applied across a media organization, right? So our thesis and our approach is a multi-engine approach. It's an orchestration layer that is our proprietary AI that sits on top of our stack and enables us to invoke different cognitive engines in series of workflows at a specific time, right? So, and what I'm about to go into is an example of a live news broadcast. So just a daily, we would ingest from iHeart, we ingest over 250 unique streams from NBCU groups and ABC. It's just obviously their national feed. And then what we'll do is we'll run automated speech-to-text transcription, natural language processing, face recognition, hyper-trained to their anchors, reporters, and contributors, OCR, optical character recognition, so they can search all the text on the screen, and logo recognition, right? And we're not just creating this metadata for the sake of creating metadata. Primarily in media, we heard about the challenges, right, of diminishing margins. And so a lot of what we focus on is advertising, and viewership, right? So how to allow our media partners to earn one more ad dollar and get one more viewer or listener, okay? So that is why we use these engines, and I'll go into the best I can while multitasking with the mic demo here. So while I log in here to a demo account, just a little background on the company. We're about 4 years old, publicly traded company. Founded by two brothers who sold their previous business to Google, again in the advertising technology space, and so that's where we focus a lot, and that will be a primary theme throughout this demo. But just to set the backdrop again, this current deployment is a cloud deployment, right? So we can containerize these engines for the cloud weary in movies, et cetera, and run these engines in our stack wholly on-prem. Or in the cloud, right? And so this is a cloud deployment of that. So our users today, we have producers, anchors, reporters, contributors, as well as assistants, advertising sales teams. They log into our applications that we've built. Nobody came to us 4 years ago asking for 2 scoops of AI. So we built some applications to allow them to invoke AI really before they cared to. In other customers, it's more of like, again, just the true API layer. So they never log in. Primarily, these are technology groups that are looking for metadata enrichment, et cetera. So they'll log in, or they won't, sorry, they won't log in. They'll just set up programmatic workflows with our API layer. And so they'll submit jobs. We'll process those, and they'll pull the results back and temporally index those in their own MAM and DAM ecosystem. So we do have, for some of our customers, what we've built, you kind of get a CMS, but just to be very clear, this is a lightweight CMS. This is not intended to be an industrial MAM or DAM, but this is basically where we store and index all of the temporal metadata that we're creating with these cognitive engine workflows. So if I drop into programs here, and again, this is just a demo account, nobody's live account, but it is a production account, right? So this is live. If you can see, these are the different programs that we've associated to the live CNN stream, right? And if I drop down into files, you're going to see these different chunks, right? So just we are chunking the live stream in this case as it comes in. Let me go to a different one that has maybe more faces in it. Keep my eye on the time. So let's go into one everybody else knows. So now I'm just dropping into Anderson Cooper's stream, right? So as his show airs, his team would be able to search and track any of this, or CNN would be able to search and track any of this within about 10 minutes of it airing, right? So near real time. Everybody's trying to drop that a lot, I understand. So this is how we visualize the metadata.
Him to be no threat to anyone or himself
You'll see
at
that
the present
this is
time.
a transcription that we've created. We can hyper-train these NLP algorithms based off the media and even the presenters.
And eventually expelled.
So you'll see that we
OTC
temporally
class with
index
the
every
shooter.
word,
The
right? So
student
when
who
we pass
says
this
that was
metadata back,
quiet, except when it came to
it maintains
talking
that
about
temporal
guns.
data, but this allows for
Always like
contextual
talking
search
about
and
guns.
discovery in
He
our
was always
platform.
asking people what kind of guns were better. If
So you can see it has that
He
karaoke
lost
style
touch with the
playback.
shooter. Then out of the blue, a message.
he requested
Face
to follow me on
recognition.
his
So this
new
again is
Instagram before
trained
everything happened,
to a
like
lot of
2 or
their
3 weeks ago.
reporters and
That
contributors.
shooter's Instagram account.
You can see
like
again,
his
We just found
there's a
out the House
timestamp for every
Judiciary
occurrence
Committee,
of that
the
face
House
appearing
Oversight
within this
Committee,
5-minute
Anderson, asking for the FBI to come in
file.
and brief them how this
text
chip
recognition.
that
So again,
came
we're
in on
scraping the
January
screen.
5th could
All
have
this
been
text, there's a
overlooked.
lot
Why
obviously
don't
because
we
they have the
follow up
ticker.
on that? We're also
It's temporally
reporting
indexed and will give me the
tonight
ability to
CNN
search
reported,
FBI
despite
admits,
this
right?
now well-documented history of mental
And then
illness,
logo recognition.
this
Okay,
shooter,
so
Anderson, bought not
this
just
is
one, but
this
5
is
guns
a great area for obviously for advertising intelligence. We're able to hyper train these logo engines, and the main use case here, and I'll get into one of those examples, is as media landscape fragments, as we all know, and we're chopping up content and pushing it faster, eventually pull. More advertising is moving into the content, right? So native-based advertising. The problem with that is when you don't have a spot log and you're in TV or radio, how do you track that? And how do you prove to your advertisers or the agencies that that actually ran? Okay, and so that is where we started. So if I go now into our discovery application, I'm gonna do just an example of a search here. So if I search by, and I'll just kind of talk. So now I'm just searching that stream for weather within 10 words of brought to you by. Okay, so obviously I'm looking for a weather integration. Okay, and so this is Boolean search. It's really a proximity search, and you can see it's pinging against the entire index that's in this, so you're getting some radio here. But now I can add something else, right? So now let me add the Purina logo. So you see 300 and something thousand weather integrations, now down to 26. Okay, and so here those are. So what I've just done is pretty powerful, right? Because now I'm stringing these different classes of cognition together, again, in an effort to get more general intelligence with these narrow engines. So you can see, it brings me right to that point where the Purina logo's in the background within a couple of seconds of him saying, if it plays. Do you guys have the audio?
Yes, we do warm up today, and it continues to go up. Even Syracuse gets above 30.
Let me start that over again.
for 40. This weather's brought to you by Purina, your pet, our passion. Yes, we do.
Right. So advertising use case. And then I want to show one other thing that's great from a strategic content perspective when you're trying to understand what is driving ratings. We're able to do something with our analytics that's pretty neat that gets utilized pretty regularly. So this is a saved search, similar to the one I just did with OCR spoken. So OCR for breaking news when it's on the screen, when it's spoken, and when Anderson Cooper's face is on the screen. Right? So you can see all the results. But now when I switch to analytics, we're able to do a more visualized representation of this. I got one more second here, so I'm just going to show you. So these are occurrences of unique Anderson Cooper breaking news stories over time on CNBC. And now I can add these different ones. So you got Don Lemon and Wolf Blitzer. If anybody watches CNBC or CNN, this won't come as a shock to you. But these are basically stacked rank of unique breaking news stories between Don Lemon, Anderson Cooper, and Wolf Blitzer over time by program, and again, the breakdown by program. So you can see, what is that, 68.6% of the time they do breaking news stories on these three shows. It's happening on Wolf Blitzer's show, which is pretty apropos. Yeah, I'm a little bit over on time. I believe it's, but please find me after for questions.
Greg Taieb is going to round up the talk up here. Take it away, Greg.
Thanks. And just so you know, I'm cramming a 20-minute presentation into 10 minutes. And I'm a little nervous, so I'm going to walk around. Craig, I'm going to run away from you when you try to grab the mic. My name is Greg Taieb. I'm the Senior Director of Localization Product Development and Strategy at Deluxe Entertainment Media Services Group. And today I'm here to talk about machine translation and time text and how it relates to the entertainment industry, where we stand today, and what the challenges are that we face before a completely automated supply chain is possible. Very quick definition: machine translation is pretty simple. It's automated translation performed by software. How many people in this room have used Google Translate to do business, talk to family and friends, or find a restroom in a foreign place? A lot of you. So you guys will have noticed that in the past few years, the quality of these translations has gone up dramatically. But at the same time, sometimes you'll enter something and the translation just flat out doesn't work. And that's because translation is extremely complex. There are a lot of layers that go into it. It's not just converting text from one language to another. There's a lot of other things that play into it. So translation's very complicated. It's more than just converting text from one language to another. I did need a visual aid for this one. So I really like to play a game called Translation Telephone. You guys can play this at home if you're really bored. But basically what you do is you take an English sentence, you feed it into a MT tool like Google Translate or Microsoft or whatever you want to use. You translate from English to Spanish, from Spanish to another language, then to a third, fourth, fifth language, and you go back to English, and 100% of the time, the results are hilarious. So we took this sentence, she awoke to the sound of a loud bang and was suddenly aware that she had fallen asleep in the middle of a technical conference that she'd been looking forward to for months. And when we translate the Spanish and back to English, there are some very obvious problems here. The most obvious of which is that at some point in this translation, the subject of the sentence became transgendered, which is awesome because it's 2018 and we respect each other's personal decisions. But for the sake of a professional application, this just doesn't play. Martin Volk, professor at the Institute of Computational Linguistics at the University of Zurich, guesses or is estimating that it's going to be about 20 years before we are at human parity with machine translation using AI. I'm sure some people in this room would disagree with that and think that it's sooner, and that's very possible. I'm sure that there will be some large advances that come suddenly. I'm going to skip through some of these slides because it's the history of machine translation. Started in the 1950s. At one point, somebody decided in like the 70s, like this just isn't working, maybe we should give up. Luckily, we kept going. And neural machine translation is the newest application, and it's the first one to actually use AI. And that's what accounts for these quality changes that you've seen in the past few years. So neural machine translation, what has people so excited is that it's only a couple years old. It's already performing better than 60 years of older technologies and research, and it's really just in its infancy. What is a neural network? Computer system loosely modeled in the human brain and nervous system, organized in layers of interconnected nodes. Recurrent neural networks feed results back into themselves to achieve dynamic temporal behavior, and which is something that other people were talking about earlier today. And basically, we can interconnect different neural networks to achieve better results, which we're not completely doing with machine translation for practical applications yet, but we're moving towards that. One quick note on speech to text. A lot of people claim parity on speech to text, human parity, which is great when there's no background noise and things like that. Unfortunately, in localization, sometimes there are explosions happening at the same time, or music which happens to fall in the same frequency range of the human voice. And for media, we find more 60 to 85% accuracy. And that is a blocker in a completely automated supply chain. So the meat of this presentation is about localization in film and television. The golden rule in localization is to keep the original intent of the director intact. Everything that the director is saying, you need to translate, but you're not just translating to achieve this, you're transcreating, hence the name of the presentation, Lost in Transcreation. So you're transcreating, and what does that mean? So translation is converting content from one language to another. Transcreation is actually taking into account colloquialisms and local preferences and tone and all these different things that apply to local cultures to make it seem like rather than the text was translated, that the entire concept of the end product was created in that local language and territory. So translation is really great. Transcreation is really where we need to excel in order to have an automated supply chain for the entertainment industry. Translating creative content is really what we're talking about. Now, Stanley Kubrick recognized the importance of this. He was a visionary and a game changer in every aspect of filmmaking, and that includes localization. For the film The Shining, there's a very pivotal scene. I'm sure most of you have seen the film, and if you haven't, you should, unless you're too scared. But there's a pivotal scene in which the main character, who's been working on a novel for months and is losing his mind, has his wife comes across the manuscript of his novel, and this is where she realizes that he's really lost it. Now, Kubrick recognized that basically the manuscript says, "All work and no play makes Jack a dull boy," over and over again on hundreds of pages of paper. He recognized that if I'm a French viewer sitting in a cinema in Paris and I'm in the film, there's tension and I'm feeling it, and all of a sudden there's a close-up shot of this text that's in English that I don't understand, it's going to take me out of the film. So he understood the importance and how important transcreation is to suspension of disbelief, which is basically everything that a director needs to achieve in order to keep his audiences engaged. So he actually had this scene translated, and not only translated, but he made different translations for different languages and had some poor assistant type them up on a typewriter for, I'm assuming, a few weeks. And then he shot those pages and inserted those for different territories to enjoy that scene and the impact of that scene in their language without being removed from the film. So let's look at some examples of nuances that go into media localization and transcreation. We have adaptation, context and tone, chunking, formatted weird, timing, and spec-based restrictions. Oh wow, okay, we'll deal with this. And these are things that a lot of the tools that some of the people up here are already working on coming up with solutions for, including Deluxe and myself. But adaptation, we adapt for local cultures, territory preference, colloquialisms, et cetera, et cetera. An example, we have this sentence, "Our cat fell into a pool of palm olive and survived. I guess he only has 8 lives left." So we have an example of a translation and example of transcreation here. So in the transcreation version, we recognize that pool might not be used the same way in other languages as we use it in this case. Palm olive doesn't exist in other countries. In Latin America, the equivalent would be acción. And then my favorite is that, this is really interesting, in America, cats have 9 lives. In Latin America and Brazil, they have 7 lives. So if we translated this sentence, somehow this cat, after falling into a pool of dish soap, would have gained a life. And that completely changes the narrative of the story and the meaning. So these are the types of things that, and this is one example, but there are literally tens of thousands, maybe even hundreds of thousands of examples of things like this for every language. And we're translating in 80 languages now, and the number of languages is going up every year. Context and tone, identifiers for satire, sarcasm, understood from visual or audio cues. So we did see some examples of how we can read visual cues and gather that data. So we need to work on using that information, combining it with machine translation to output some usable translations. Humor is another huge one. Jokes don't play the same way in different countries. One of my cousins in France, one of his favorite movies growing up was Trading Places, as was mine. And we watched it together a few months ago in English, and he hated it because he's like, this isn't funny. These aren't the same jokes, which seems counterproductive. But in reality, the jokes were different, but he had the same experience growing up watching that film than I had. So him watching it in France, he had the same experience that I had watching it in the US, and that makes for excellent transcreation. Chunking is, it's spelled correctly this time, is basically natural pauses in language. So you don't want to insert a pause in a language in a place that's unnatural because, again, that plays into suspension of disbelief. If somebody makes an unnatural pause in a sentence, it seems a little weird and distracting to the audience, so they can get pulled out of a scene from this. Another thing is sometimes in languages, grammatically, the structure of sentences might be reversed. So you don't want to give up that someone's about to die 3 seconds before it happens on screen, or else that would ruin the content. And then timing and spec-based restrictions. I really hate that in this industry, every single broadcaster, every OTT platform, every content owner has their different specs, and this actually makes a difference as well. Most specs allow for 42 characters per line, for example. French broadcast only allows for 37, and that's a 12% loss in real estate of the amount of time that you have to translate something. And that's another important piece. Subtitling isn't just translating, you're also truncating the dialogue. So that plays into it as well. I gotta go through the next 10 slides in 11 seconds. So machine translation is great for translation. What'll make it great for transcreation? Training neural networks. Basically using the data corpus that we have to train neural networks and feed the results back in and validate the results using humans right now to retrain. I'm gonna skip through some of these slides. I'll give you time to read. And you know what, we'll make this available online so you guys can see the rest of the presentation as well. Accuracy right now is, it varies widely depending on method and language. And the good news is that we said that the quality of MT translation is dependent on the quality of the data corpus we train with. In Hollywood, I mean, even specifically at Deluxe, we have tens of millions of hours of translations that were created by professionals, transcreations created by professionals, which we can feed into neural networks to train. So, we have a lot to do. We know what it's going to take to get there, and we have the tools that we need to get there as well. How do we use it today? As an aid. Typically you have text, it's translated by a human, and then it's QC'd by another human, and then it goes off into the rest of the supply chain. What we're starting to do now is have a machine translation as a starting point, and we have a new role of what we call a post editor, who's half QAer, half translator, who validates incorrect translations, and they validate correct translations, and they make adjustments to incorrect translations. Send that off to the client or the supply chain, and then at the same time, feed that information back into the neural network to learn. This is also a challenge because obviously translators don't want to be training the machines that are eventually going to be replacing their jobs. And so it requires somebody who's willing to participate in that. We also use it for back translation. Pre-delivery checks, we can translate foreign subtitles back into English so that non-foreign speakers can check timing and make sure that the content of the foreign subtitle is from a back translation to English, matches at least loosely the content of what's happening in the English subtitle at the time. And we use a distributed workforce to achieve this. So basically in the future, we need to train different neural networks to account for facial recognition, tone recognition, machine translation, colloquialisms, all these different pieces, and output a usable subtitle file. And we're lost in transcreation right now, but once we've resolved the blockers identified today, it will be Suntory time. So thank you guys. Sorry I went over, and sorry, Craig. Thanks for not chasing me.